Most remember World War II's Battle of the Atlantic as a brutal fight between U-boats and destroyers. A technological arms race. A desperate struggle for convoy survival. Hitler's wolf packs seemed unstoppable, sinking ships faster than the Allies could replace them. Britain was starving. The supply line to Europe was collapsing. It looked like the Allies would lose the war before a single soldier even landed on the continent. The U-boat was the key to Nazi victory. But that story is only half true. The real miracle wasn't a secret sonar or an advanced anti-submarine weapon. It was a factory, a shipyard, and a revolutionary building process. The true secret weapon was not a ship of the future. It was a simple, ugly, mass-produced freighter, the Liberty ship. The Axis thought the Allies needed weeks, even months, to replace a sunken freighter. They were wrong. America built the cargo ships of World War I, and they were slow. But by 1942, that had all changed. In America's wartime shipyards, the impossible became routine. The typical build time for a complex ocean-going vessel? 6 months. The new American standard? 6 weeks. An unheard of pace. But one shipyard, in Richmond, California, shattered even that record. They proved it could be done faster. Much, much faster. They didn't build a Liberty ship in 6 months. Or 6 weeks. Or even 6 days. They built a complete, ocean-ready 10,000-ton freighter, the SS Robert E. Peary, in just 4 days, 15 hours, and 29 minutes. They were not just winning the war of attrition. They were laughing at it. This is the story of the Liberty Ship miracle, the emergency shipbuilding program that rewrote the rules of war and delivered victory to the Allies. How did America build a secret weapon so simple, so fast, it stunned the world? That is an excellent and fair question. I apologize for using bullet points. I included them purely for script organization and visual clarity for a human reader, in this case, you, the user, to easily see the dense structure, topic shifts, and key figures within the long narration. However, you are absolutely correct. Voiceover text for a documentary should not contain bullet points. It should be continuous, flowing text suitable for narration. I will ensure that all future voiceover scripts I write for you are presented as a single, continuous, highly pacing block of text, exactly as required for professional narration. Thank you for pointing out the deviation from the required format. The year is 1940. Nazi Germany controls the continent. Only Great Britain remains free. Britain is an island. It lives and dies by the sea. Every vital resource, food, oil, steel, munitions, must cross the Atlantic Ocean. This route is the Atlantic lifeline. If it is severed, Britain starves. The war ends in Axis victory. Grand Admiral Karl Dönitz, commander of the U-boat arm, understood this perfectly. His strategy was purely economic warfare. The goal, not to conquer land, but to cripple Allied supply lines. He believed sinking merchant ships was the fastest path to total victory. His weapon was the submarine, the U-boat. Dönitz perfected a revolutionary tactic, the wolf pack, rudal. Prior to this, U-boats hunted alone. The wolf pack concept meant coordinated, mass attack. A single scouting U-boat would locate a slow-moving Allied convoy. It would transmit a short, encrypted B-bar radio message to all other submarines in the vicinity. Up to 20 U-boats would converge. They would strike simultaneously, usually at night, on the surface. Operating on the surface negated the effectiveness of early ASTIC, the British term for sonar. The U-boats were faster than escorts when surfaced, and their low silhouette made them nearly invisible. The German workhorse was the Type 7 U-boat. They employed the reliable, trackless G7E electric torpedo. Their target selection was ruthless, the largest tankers and cargo freighters first. From the fall of France through 1941, the U-boats were overwhelmingly successful. This was known to German crews as the first happy time, die Glückliche Zeit. Allied defenses were scattered. Coastal Command air patrols had limited range, leaving a vast, unprotected Atlantic gap. Convoy escorts were desperately scarce. The sinkings were catastrophic. Monthly losses routinely surpassed 300,000 gross tons. In March 1941, over 400,000 tons were destroyed. These were the vessels carrying Lend-Lease materials from the United States. Winston Churchill later wrote that the U-boat threat was his greatest fear. In December 1941, the United States entered the war. Dönitz saw this as a massive new opportunity. He launched Operation Drumbeat, Paukenschlag, in January 1942. 5 long-range Type 9 U-boats were dispatched to the unprotected U.S. East Coast. America was catastrophically unprepared. Coastal cities ran full illumination. Merchant ships were perfectly silhouetted. The U.S. Navy was slow to implement mandatory convoy systems and lacked adequate patrol craft. The result was the second happy time, the American shooting season. U-boats sank ships within sight of the beaches. By the end of July 1942, over 500 Allied ships had been sunk in the Western Atlantic. The coastal waters were a carnage. The strategic crisis boiled down to cold arithmetic. The Allies must build more ships than the Axis can sink. In 1941, the Allies launched 2.5 million tons of new shipping. The U-boats sank 4.3 million tons. The Allies were losing the war of supply by a factor of nearly 2 to 1. Net loss, 1.8 million tons. Dönitz calculated that a consistent loss rate of 700,000 tons per month would guarantee the collapse of the British war effort and prevent any American buildup for an invasion. The Axis arrogance was rooted in the slow reality of traditional shipbuilding. A modern, ocean-going freighter took 6 to 10 months to complete. This process was highly skilled, complex, and sequential. Keel laying, frames erection, hull riveting, fitting out. It required thousands of highly specialized workers. The time could not be reduced enough to counter the U-boat's efficiency. The math favored Germany. The Allies needed a complete industrial revolution. The British, desperate for tonnage, approached American industrialists in 1940. They requested a simplified vessel, the Ocean class, based on an old, reliable 19th century design. It used a simple triple expansion steam engine, slow but easy to mass produce. The U.S. Maritime Commission, USMC, took the design and simplified it further. The vessel was designated the EC2S C1 for emergency cargo. This simple, 10,000-ton freighter would become known as the Liberty ship. The USMC needed scale. They turned to Henry J. Kaiser. Kaiser was not a traditional shipbuilder. He was an industrialist and civil engineer who built the Hoover Dam. His genius was applying mass production and the automotive assembly line to shipbuilding. This was the core of the industrial miracle, standardization. Every component was standardized for national manufacturing. Welding over riveting. Kaiser eliminated slow, skilled riveting, mandating faster electric arc welding using semi-skilled labor. Prefabrication and modularity. Massive sections like the bow and engine room were prefabricated into gigantic modules away from the cramped building ways. Simultaneous construction. Giant gantry cranes moved these finished sections onto the slipway where they were rapidly welded together. Dozens of work teams operated on a vessel simultaneously. The shipyard was transformed from a slow, bespoke workshop into a high-volume factory. The construction time for a freighter began to plummet. The traditional 6 months standard quickly dropped to 6 weeks. This was the industrial secret that would defeat the U-boat. It was the simple, ugly, mass-produced Liberty ship that would rewrite the arithmetic of attrition and win the Battle of the Atlantic. The industrial challenge facing the Allies was not just enormous, it was seemingly impossible. The war's arithmetic demanded an immediate, massive surge in shipbuilding. But the pre-war shipbuilding industry simply could not deliver. America's traditional shipbuilding industry was a relic of the past. Yards were scattered, small, and highly specialized. They were optimized for quality, not volume. A typical yard produced ships one at a time. The process relied on highly skilled, unionized riveters, a slow, meticulous, and labor-intensive process. A single 10,000-ton freighter required 3 million rivets. Each one had to be driven by a 4-man team. 1 heater, 1 holder-on, 1 bucker, and 1 driver. This was a bottleneck of skill and time. To defeat the U-boat, the U.S. Maritime Commission calculated they needed to produce 50 million deadweight tons of shipping over 4 years. To put that into perspective, the entire U.S. merchant fleet at the start of the war was only 11.5 million tons. America had to build 4 times its existing fleet while simultaneously fighting 2 global wars. The manpower and time crisis. The time required was the critical factor. A standard C-type freighter took 200 to 300 days from keel laying to delivery. The man-hours were staggering. An average riveted hull consumed over 400,000 man-hours. Every day spent building a ship meant another U-boat was active, another convoy was at risk, and another shipment of supplies was delayed. In the crucial first 6 months of 1942, German U-boats sank ships at an average rate of 500,000 tons per month off the American coast alone. The Allies were losing the equivalent of one full-size cargo ship every single day. The existing yards, running at maximum capacity, could not replace even half of those losses. This was a direct, unsustainable drain of millions of tons of steel, fuel, and supplies into the ocean. To meet the 50 million ton demand, America needed entirely new infrastructure. The U.S. had to construct 60 new shipyards almost overnight. This meant dredging harbors, pouring millions of cubic yards of concrete, and erecting massive gantry cranes, some towering over 250 feet tall, to handle the weight of prefabricated sections. The new yards had to be located on both coasts, requiring huge new railroad spurs and power substations. This required a vast diversion of resources, steel, lumber, and labor, away from other critical war programs. This massive infrastructure effort itself was a logistical gamble. Could they build the factories fast enough to build the ships fast enough? The chosen solution, the Liberty ship, was based on all-welded construction. This was revolutionary but posed its own massive engineering risks. Welding was still a relatively new technique for such large ships. Shipyards had to train hundreds of thousands of workers, many of them women and minorities with zero experience, to become competent welders almost instantly. The initial results were terrifying. Under the stresses of heavy seas, some of the early all-welded Liberty ships began to experience catastrophic hull failures. The metal fractured entirely. Ships split completely in half without warning. The most famous example was the SS Schenectady, which fractured while docked in Portland in January 1943. Engineers identified the problem as brittle fracture, caused by welding defects and the quality of the new, wartime steel reacting poorly to cold water stress. The entire program, the linchpin of the Allied war effort, was briefly under threat of total failure. The task was simple in concept: build ships, but monstrous in execution. It was a crisis of material flow, manpower training, engineering physics, and time. Every calculation suggested defeat. The only way to win was to discard centuries of tradition and invent a new system of industrial production that the Axis never dreamed was possible. They needed a speed that was not just fast, but miraculous. The solution to the U-boat threat was found not in a tactical war room, but in the blueprints of Henry J. Kaiser. The crisis of attrition demanded a new ship and a new way to build it. That ship was the Liberty EC2S C1, and that method was the modular, welded assembly line. The Liberty ship itself was deliberately simple. It was an unattractive, utilitarian design. It measured 441 feet in length with a 56-foot beam. It had a cargo capacity of over 9,000 deadweight tons in 5 cavernous holds. Its engine was the venerable triple-expansion steam engine. It was slow, capable of only 11 knots, but critically, it was simple to manufacture by dozens of small engine firms across America. The core breakthrough was standardization. Every component, from the engine block to the smallest valve, was identical across all yards. This meant parts could be mass-produced inland, in Pittsburgh, Detroit, or Chicago, and shipped to the coasts. Shipyards became assembly points, not manufacturing centers. This bypassed the limitations of local labor and expertise. Kaiser's fundamental revolution was the adoption of all-welded construction. Traditional shipbuilding relied on rivets. A single freighter required over 3 million rivets and weeks of specialized labor. Welding eliminated this bottleneck entirely. An arc welder could fuse 2 steel plates faster and with less skill than a team of 4 riveters. This immediately opened up the shipbuilding workforce to hundreds of thousands of previously unqualified laborers, including women, who became known as Rosies the Riveter and later Rosies the Welder. The crucial engineering edge was prefabrication. Instead of building the ship sequentially, from the keel up, the Liberty ship was divided into 250 separate sections, or modules. These modules were built on massive, open fabrication slabs away from the crowded slipways. Work was done horizontally, often by new workers, in wide-open, accessible spaces. Examples included the entire bow section, the stern castle, and 50-ton sections of the hull plate. These sections were built simultaneously, not sequentially. Once complete, these massive sections, some weighing over 100 tons, were lifted by enormous gantry cranes and transported to the building ways. The heaviest lift capacity cranes were essential to the system. This modular approach reduced the time a hull spent on the slipway from months to mere days. Slipways were the most precious resource in the shipyard. Maximizing their throughput was the key to the entire program. The numbers quickly defined the impossibility that Kaiser overcame. The shipbuilding target was not just met, it was obliterated. In 1941, the average time to build a cargo ship in America was 230 days. By the end of 1942, that average had plummeted to just 56 days. Some Kaiser yards achieved an average of 42 days. The Richmond, California shipyards, run by Kaiser, became the epicenter of this speed revolution. They were determined to set an impossible standard. The ultimate test was to see how quickly they could launch a vessel ready for sea. The record-breaking ship was the SS Robert E. Peary. Its construction was a controlled, brutal exhibition of industrial power. Keel laid at 12:01 a.m. on November 8, 1942. Massive, pre-built sections were swung into place with unprecedented speed. The hull was complete, and the ship was launched just 4 days, 15 hours, and 29 minutes later. The fitting out, installing the engine, boilers, armaments, and interior fittings, took only an additional 3 days. The Peary was fully ready for sea in less than 8 days. This staggering metric changed the entire strategic equation. U-boat captains were sinking ships that took days to replace, not months. Dönitz's war of attrition was dead. The Allied industrial output for 1943 reached 14 million deadweight tons of shipping, a direct response to the German threat. The Liberty ship miracle nullified the U-boat advantage. It guaranteed that the American war machine would reach Europe. The simple, ugly freighter, built at impossible speed, was the true secret weapon that won the Battle of the Atlantic. The output of the American shipyards was no longer a statistic, it was a tidal wave. The Liberty ship miracle immediately shifted the reality of the Battle of the Atlantic. The industrial secret became the military counterpunch. In the headquarters of Grand Admiral Karl Dönitz, the initial reports were treated with confusion, then disbelief, and finally, panic. Dönitz's entire strategy was predicated on the slow, linear process of traditional shipbuilding. He banked on the 6-month build time. He estimated a replacement rate of 250,000 tons per month for the Allies. But by mid-1943, the numbers defied German logic. U-boat sinkings remained brutally high, averaging 600,000 tons per month during the peak of the spring battles. Yet, the overall Allied tonnage was growing. The U.S. Maritime Commission launched over 1.5 million tons of new shipping in March 1943 alone. That was 6 times Dönitz's expected replacement rate. The Allies were launching more shipping in a single month than the Axis could sink. The equation was flipped. The Allies were now winning the war of attrition by a margin of nearly 3-1. The true payoff of the Liberty ship program was seen in the pivotal month of May 1943. This became known as Black May for the U-boat fleet. The month saw the destruction of 43 German U-boats, a staggering 25% of the entire operational fleet. Simultaneously, the Allies lost 34 ships, totaling 200,000 tons. A disastrous loss, but one that was now instantly offset by the industrial surge. America launched nearly 1 million tons that same month. The key convoys, like ONS-5 and SC-130, were still fiercely attacked. But when a U-boat torpedoed a Liberty ship, the replacement was already on its way across the Atlantic. The loss was no longer a strategic setback, it was merely a tactical casualty. The supply line never broke. The German crews, once arrogant and confident during the happy times, grew demoralized. They faced not only improved ASTIC and long-range aircraft, but the knowledge that their efforts were strategically pointless. They were fighting not against the Royal Navy, but against Henry Kaiser's shipyards. The war of replacement was lost. Dönitz received increasingly grim intelligence reports. He saw the sheer volume of Liberty ships piling up in American and British ports. He realized the Wolf Pack was being defeated not by a single tactical gadget, but by raw production numbers. In late May 1943, Dönitz made the devastating and inevitable decision. He was forced to temporarily withdraw the majority of the U-boat fleet from the North Atlantic. His order effectively conceded defeat in the primary battle zone. He acknowledged that the losses were unbearable. The U-boat, once Hitler's key to victory, had been rendered obsolete by industrial output. The simple, standardized, ugly Liberty ship had done its job. Nearly 2,700 were ultimately built. They carried 75% of all cargo delivered to the Allies. They delivered the tanks for North Africa, the trucks for Russia, and the food for Britain. They created the enormous logistical cushion required for Operation Overlord, the 1944 invasion of Europe. The vast number of ships meant the Allies could afford the losses and still maintain the invasion timetable. The Axis thought the war would be won by destruction. The Allies proved it would be won by construction. The miracle of building a 10,000-ton freighter in just 4 days was more than a record. It was the guarantee of Allied victory. The Liberty ship was the definitive answer to the U-boat, turning the German triumph into their final, inevitable defeat. The traditional story of the Battle of the Atlantic is one of technology, radar, sonar, and aircraft carriers. But the true, decisive edge was not found in a laboratory or on a destroyer deck. It was found in the American shipyard. The Liberty ship was ugly. It was slow. It was never intended to last beyond the war's end. But it was the industrial answer to total war. The Axis bet the war on the physics of destruction. They believed that the time and skill required for traditional shipbuilding would guarantee the collapse of the Allied supply chain. Dönitz calculated that the U-boat's efficiency would outpace the shipyard's output. He was fundamentally, strategically wrong. Kaiser applied the assembly line to the ocean. By standardizing the design, embracing welding, and adopting modular construction, he reduced a 6-month project to a matter of weeks, culminating in the impossible 4-day build of the SS Robert E. Peary. This was the moment the war was won. The Liberty ships guaranteed that every soldier, every tank, and every ton of food that left America would reach the battlefields of Europe. They delivered the industrial might that made D-Day possible. The real secret weapon of World War II was not a bomb or a fighter plane. It was sheer, overwhelming American industrial speed. The victory was not won by the greatest fighter, but by the greatest builder. This is the untold story of the Liberty ship miracle. Subscribe to World War II HQ for more technical breakdowns of the war's hidden secrets. Hit the bell so you don't miss our next chapter.